So what is the smallest area? The smallest area of a tilted square? 2. Now, why is it 2? Why is the area of this one, that tilted one, 4? I want to hear from one good explanation because I don't see that it's 2. John.
Yeah.
John. Yeah.
I think it's 2 because if you count, if the what do you call them? You call them grid points?
Yeah.
Grid points. Right. If you identify them with an integer lattice, so if you go horizontally from one grid point to another, that's 1 unit. Then the side of that square is the diagonal of a 1 by 1 square, which is square root of 2.
Well, how do you know that?
Because Pythagoras.
What about being very, very simple? What about trying to forget that we know advanced stuff like Pythagoras theorem? If I had a terrible case of amnesia this morning. When I was driving here, it took me forever, and I just forgot all about Pythagoras theorem. I forgot Pythagoras theorem. I don't know. And I even forgot square roots. I don't know what you're talking about. So, is there an easier way? Okay, diagonal divides the square in half, so this part is the same as that. So we have 4 halves, right? Okay. I buy that, I understand that, I still can understand that. I don't know whether I would still understand that argument by tomorrow, but today I still understand that. Everybody agrees that it's actually 2 because we have just 4 halves. Alright, good. Now, what's the next size? What's the next size? Is this the next size up? Now, this is another question that actually might be a useful thing to try and really go into depth and trying to understand why this is the next one. How can you convince your neighbor, your friend? Can you convince that this is the next biggest, the next size up, that we cannot have any size between this and that when we're talking about tilted? Now, I don't go into that because we don't have time, and there is always a good thing to leave something that you feel not so comfortable with that. I'll come back to it, and I will try to convince myself and everybody around that this is the case. But now, if we do agree, I heard 5. Everybody agrees that this is 5? Raise your hand if you have doubts that the size of this guy is 5. Raise your hand if you have doubts. I have doubts. Can you convince me? Please, someone. Glenn.
Well, it covers, take the...
Come.
Take the area around the whole thing is...
around the whole
9.
Okay, so...
That's 9, and each one of these over here is 2, but you take off a half, so that'd be a half, and a half.
So it's
half of 2, so it's 1. Yeah, thank you. And so we'd have 9 minus 4, which is 5.
That's totally beautiful. Everybody agrees? It's just counting. It is not. We do just counting, nothing else. And also, we believe that all grid squares are born equal, right? Every square of the grid has area of 1. So if you have this rectangle, then its area is 2, but this diagonal cuts it into half, so what we leave out is 1. Everybody agrees? Okay, so now we have that 9 minus 2 times 1 is 5, right?
2 times 2 times 2.
4 times 1.
4 times 1.
Yes. Now, is it 4 times 1? And why is it 4? Oh, because there are 4 of them, right? Okay, good. So, we have 5. I agree. What would be the next one? 8? And how do we get 8? How do we get 8? If we start here, where do we go? Down 2 over 2, so we have this, right? And then we have this, and we have that. In fact, it's kind of interesting. How can we get this guy starting with that? Yeah, we stretch it by a factor of 2 in both directions. Everybody agrees? And when you stretch it in both directions by a factor of 2, what happens with the area? It gets multiplied by 4, right? Now, how can we really see that? If you start with just one square like that, stretch it vertically by a factor of 2, what do we get? We have a rectangle, right? It's not a area 2. It changes the shape. But now, if you stretch it by a factor of 2 in the opposite direction, it becomes now what? Square again. So we have this rectangle, and if we take that rectangle and stretch it by a factor of 2 horizontally, now it will be this square. And the area becomes 2 times 2, 4. So that's one idea that also, again, is there for discovering and for discussing and for thinking about.